Welcome. Oh my god. Welcome back to Daily LeetCode. It is day 106, and we are back once again. You never really get too much time away from LeetCode. It always comes a knocking. You know what they say, there's only two things confirmed in life, and that is death and the weekly contest, the LC weekly contest. So that's what we're going to be doing today. I really would like to try that last problem. Or maybe we could do it like we just try. We just try it for that one session and see how far we get. But that wouldn't be very cool or pog. But we have a lot of comments today. So I figured we would go through those first as per usual. And then we'll jump in. I think I have some ideas of some things. But we have someone that says, Guy, thank you for the motivation. Help me take a different look at what I was doing. Thank you for your motivation. God bless. Oh, I clicked cancel. Oh man. But I'm just gonna click one of these buttons. Glad I could help. Feel strong, man. Feel strong. Yeah, it's really cool. I only did this because Ivan Jurek does squatting every day, so that's pretty cool. And yeah, maybe you could also make videos, and then I'll watch them too. And that would be pretty cool. Your big mouse kind of annoyed me. Wait, I don't know if I ever showed my mouse. That'd be pretty funny though. It's a pretty thick mouse. Gonna make it big, bro. What does that mean? Love. You're gonna be bigger. Feels strong, man. Probably set up debugger and watch the. Oh yeah, true. So weekly contest 312. I couldn't figure out why something was happening, and Freeman mentioned I should probably set up a debugger and watch all the values change at runtime. True. I thought LeetCode had a feature like that, and I don't know. I couldn't get it. I feel like a year ago they had that feature. I really feel like they had that feature a year ago, but maybe they don't anymore. Maybe they took it out. Maybe it was hard to maintain. Oh my god, my mic wasn't even in the right spot. Oh no. Okay. Yeah, I really thought they used to have that feature, but I'm not really certain. So I'll look into it, but I really thought they had it. And yeah, I was doing some thinking, and I think structurally, I think we lost our way. Originally, the way the challenge started, not the challenge, but originally the way I had, also I was watching the videos back, and I think I talked too fast. Originally, the way I had set up the work, I was able to get, so I do like LeetCode for like an hour, 45 minutes to an hour, but it took me a long time to work up to that number. And I think I used to just slowly work up, because in the Atomic Habits book they always mention you should slowly add difficulty and stuff like that. So you should mostly focus on doing the activity, right? And I think the reason that they say that the most important thing is to just worry about starting is because I think the hardest task is just starting. And I think when the daily everyday thing showed me that, I thought I was practicing LeetCode for the first 70 days. What I was really doing was just practicing showing up. And then after a certain point, showing up didn't take that much energy, and then I was able to kind of actually do LeetCode. But I would say in the beginning, if you imagine it like a fuel tank, and I imagine myself as a really, really bad car, it took about 90% of the fuel tank just to start the car. And so when I started the car, I couldn't really go very far. And now, kind of optimize some of that difficulty away, and I can go a little bit further. But I think at some point, I got used to the new distance I could go, and I stopped optimizing. And I think that is an issue. So I think I might have to go back to the roots, because I think I was doing like 3 or 4 hours a day. There was even a point a long time ago, not a long time, maybe like a month ago or a month and a half ago, we were doing like 6 or 7 hours a day, and it just wasn't very useful. And I got thinking about a question and it made me think about diminishing returns. And yeah, I think there's definitely diminishing returns. I don't think there's diminishing returns. I feel like you have to think about multiple different kinds of learning. I feel like when I'm just thinking about, oh, I'm solving a problem, I feel like that is there's a lot to give there. But when I like to think of the mental model or whatever, it's kind of like this really expansive decision tree. And I think the reason there's diminishing returns is because it takes so much brain power to load the entire decision tree in, a lot like a neural network. It takes so much memory, and then once you have it in memory, then you have to slowly change or tweak certain parts of it, and then afterwards it kind of feels like it's the same decision tree, but it's not the same decision tree. And I think that thing has a cooldown. I feel like when you change it too much, the whole thing just gets messed up. So what I'll try and do is, to avoid that, I'll try and maybe only do like 30 minutes to an hour per each subject. And that really helps with that, because then I could learn in one space, then kind of reach my cooldown, learn in another space. Or I think you could also learn in one space, have like a few hours of cooldown or something, and then learn another space. But I don't know, that's just how, kind of like doing a random walk through all this self-learning stuff, I kind of figured that out for myself. But yeah, I don't really know. But I think I got to get back to the roots, because I think I was talking yesterday about the ship analogy. I think the ship is definitely overloaded. And I think I would say I'm sprinting now. And because I'm sprinting, because usually my focus is more on the long term, so I'll just set up something for long term. The LeetCode thing is just a long term setup. But usually I'll set up something for the long term. And this was not the case. It's still the case, but I got really impatient. So I started doing a lot really soon. And I think it's just better to do how I've usually done in the past, which is a slow ramp up. And then with the slow ramp up, it's also easier to test minor changes to the system. And it all sounds convoluted. Sometimes I think to myself, why do I have to do all these different things just to get a few things done? But I'm not exactly sure why. I think I stopped asking that question a long time ago. And I don't know. I think maybe it's not. Yeah, I'm not sure. But I do ponder why I have to. It feels like I have to solve a puzzle just to build some discipline. But this LeetCode thing has been pretty good for building that discipline. So yeah, I think the way I'm going to structure the learning is going to change. The LeetCode videos aren't going to change. It's still going to be 45 minutes to an hour, or 30 minutes to an hour. Mostly just going to be an hour still. But I think the learning I'm doing outside of that, I'm going to change the structure. Because I think it may be too much. Because it definitely, each day is pulling into the next day. And at the same time, I was thinking about trying to wake up earlier. For some reason, I've been able to wake up, but I can't wake up. It's like I'm capped at a specific number. And for some reason, I can't wake up earlier than that. So I'm not exactly sure why that is. But yeah, for some reason I seem to be capped by that. Maybe I was going to try and get some Philips. Okay, this might be crazy, but I was thinking about getting some Philips Hue bulbs, and then I was going to put one right above my head while I sleep. And then I was going to set the bulb to turn on exactly when I'd like to wake up, just to make the process more uncomfortable, so I could just force myself out of bed. But I wonder if I would just turn off the lamp right next to me. So maybe I should make it so that I can't turn it off. But yeah, I would say I really would like to wake up earlier, but I'm just not certain how to get past that blockade. We're able to wake up relatively early, which is cool. But I would like to wake up about an hour and a half earlier than I do now. And that would be ideal. But but I just can't figure out how to do that. So we're gonna treat it like LeetCode and sit on it, and then maybe we'll figure it out, and then everything will be okay. But besides that point, I would be able to wake up earlier if you joined the HCC, because the HCC needs you. The Hyperbolic Coding Chamber is rapidly growing, and you're gonna want to join because we have some pretty big-brained individuals in there. I'm getting lessons from them. They're showing me the way, and so if you want to know the way, you're gonna want to join the HCC. And yeah, so we're gonna jump into it today. I'm gonna try that last problem in the weekly contest, and then we shall see how it goes. So let's just jump in to it. My timer is gonna be slightly off, but that is okay. So let's do it. So we were finding one last problem. We did, I think if we refresh this, I think we did the first two, but I'm not exactly certain. Well, now it says we didn't do them, but I'm pretty sure we did the first two. Or maybe you have to do it all in one session. I'm not exactly certain how it works. I didn't read the paragraph. But we'll try it, and then 20. Yeah, well, we're gonna try and do find all good indices. I think we've had a problem like this before. And then I'll make sure to make my camera smaller, because that was egregious last time. And then, yeah, let's just jump into it. So, given a 0 indexed integer array nums, 0 indexed integer array nums of size n and a positive integer k. So you have two inputs. One is a 0 indexed integer array. One is a positive integer k. We call an index I in the range good. It has to be in the range. K is less than or equal to I. And I is less than n minus k. If the following conditions are satisfied, the k elements that are just before the index are in non-increasing order, so they're decreasing, and the k elements that are just after the index I are in non-decreasing order, so they're increasing. So the ones before are going down, the ones after are going up. Turn an array of all good indices sorted in increasing order. Interesting. So the indices, right, for each one, at minimum, it seems you need to have an indice that can have at least k elements behind it. So you have to start at minimum at index equals k. Then from there, you want to be able to check that these two are decreasing, which they are, and these two are increasing, which they are. And so index 2, you put 2. And then apparently index 3 is also good. These are in non-increasing order. I see. So if the elements are the same, that's also okay. And the two k elements afterwards, the two elements afterwards are in non-decreasing order, so they're increasing. But there's no other one that follows that pattern. If we go to 3, we're having in non-increasing order, but 4-1 is decreasing. We don't want it to decrease. Interesting. It looks like there are no good indices in this array purely because there's not enough elements on both sides. So if you choose this one, you don't have two elements, but you get increasing, which is good. If you choose this one, you get, if you choose this one here, you get non-increasing, which is decreasing, but you don't have enough elements here to finish the good. I get the vibe that this could be a sliding window problem. and we'll just do it in TypeScript this time. I get the vibe that this could be a sliding window, but with 3 windows problem. And n is equal to nums.length. We're always given at least 3 elements in the array. The numbers range from 1 to 10 to the 6. And k is always at least 1 or less than n over 2. Okay. Interesting. We should array of all good indices sorted in increasing order. Okay. And then after you get those indices, you could sort them afterwards. Indices afterwards. Okay. Okay, so maybe we could yeah, could be an issue where we have to perform k operations. So I'm thinking that we might end up doing, since k is variable, and you have to be able to check it behind the indice and after the indice, that we would end up doing something like n times k operations or n times 2k operations. N times 2k operations. So maybe that wouldn't be so bad. Well, I think we just worry about getting it right first. So we would start at index k, check if it's increasing, and then check if the range after it is increasing. Check if the range before it is decreasing, non-increasing, and check if the range after it is non-decreasing. Then if that's true, it looks like worst case. I'm trying to do the algorithm. I'm trying to figure out the time complexity beforehand, but I think we should just try this. I think we should just try this. So it seems like none of my key bindings are working today. So it looks like we'll want to start at index k equals, start at index k, maybe declare func to check non-decreasing and non-increasing. And then if it's true for that index, if true for that IDX, add it. So where IDX is after. Let's see if that would work. It is non-increasing, and then here we have it is non decreasing, so we're good. We'd have the same thing here. Then we'd go to 3. We'd be good here, but not good here. Then we'd be done. And we could say start index k and end at n dot length minus k. Let's see, for this one, I think we would be good. Can I come up with a solution for that one that does is there one that doesn't work for that? And it would actually be start at index k plus 1. Actually, no. Because of the 0 index, we get lucky. So let's try that. So we want to start at index k. So we could just do a loop. So that could just be from k up to n dot length. Oh, I'm writing in Ruby. That would be for let I equals k. I is less than nums dot length minus k. And then we just make sure that makes sense. We have this array here. It has 1, 2, 3, 4, 5, 6, 7 elements. 7 minus 2 is 5. So 0, 1, 2, 3, 4, 5. Zero, 1, 2, 3, 4, 5. Wait, no, it doesn't have 7 elements. It does. 0, 1, 2, 3, 4, 5, 6. 7 elements. 7 minus 5 is 7 minus 2 is 5. 1, 2, 3, 4, 5. Yeah, that would work because we'd stop as soon as we get to 5. It wouldn't be this. 5 would be equal to nums dot length minus k, which means we wouldn't use it. Say I plus plus. And then we need a function declare to check non-decreasing and non-increasing. And then we could have something like indices, which would be an array. Indices dot push I. And we could just say if return an empty array for now. Then I think we would need to implement non-increasing. It would take a number, an index, and it actually looks easier if it just takes k, which is a number, and then I, which is also a number, returns a boolean, and then I'll swap it like this. And then basically, we want to check the k elements before it. This is non-increasing, so this is after it. We'll say, what is it? subarray, the k elements that are at index I, like I minus 2, the k elements in that range just before the index I are non-increasing, which I think just means we're already passing an I. We'll just say inner equals 0. While inner, actually, where does a non-increasing is for before the index I. So if that's the case, for index I, which means if we were in this one right here, we start at k equals 2, right? And I would be equal to k. We do k, we want to start at I minus k, which would be 0, and then say while inner is less than I, inner plus plus. And then we'll say if nums sub inner is greater than nums sub inner plus 1, return false, otherwise it return true. All right, because if num sub inner, let's just say 2 is greater than 1, are non-increasing. Non-increasing means decreasing, but also allowing for equivalence. But this has to be wrong to start, because I'm saying if 2 is greater than 1, return false, and this is a good indice. I think what I want to say is if num sub inner is less than inner plus 1, return false. And just to make sure that this is working, we have nums, right, which is this array here, k, which is 2, and I, which would be 2. Go in here, and it would be I minus k. I is 2 here, and k is also 2, so inner would be equal to 0, so we'd be at 2. Going up to inner is less than I, which is index 2. We'd say, okay, num sub inner, which is 2, is it less than nums sub inner plus 1, which is 1? No. So we keep going. Is 1 less than 1? No. And then 2 is inner is equal to 2, which is equal to I, so we stop. We'd return true. Whew. Now I think non-decreasing would be the opposite of this, right? Because we want to start at 1, and we want to start at, if k equals 1, we want to start at, actually, yeah, we can start at 1. Or we can start at k, or at I, is what I'm saying. We can start at I, and just make sure that 1 and 1. We want to be non-decreasing, so that's not a decrease. And then from 1 to 3. Now, if 1, right. So if 1 is less than 1 is less than 3, then that would be an issue. Wait, does that mean these two are that doesn't make sense. There's no way. Non-increasing. We want these to be going down. That's what we're checking for. Inner. Want them to go down. So we want the false case. So we flip it. So if 2 is less than 1. If 2 is less than 1, then we would return false. 2 is not less than 1, so we keep going. And then, yeah, if we say if 1 is greater than 3, we'd have an issue. But 1 is not greater than 3, so we're fine. And then we want to actually start at I here. And then go while inner is less than I plus k. I equals k. I think this should work. I mean, just to get the indices, but we get index 2 and 3, which was the ideal outcome. And then they said to sort it in ascending order. Sort it in increasing order. So we'll say indices I don't feel like this should work. Or either I'll get TLE. Maybe they are wanting a specifics. So our output is 4. Our expected was 4, 5. So 0, 1, 2, 3, 4, 5. Five minus 1 is index 1, so we started 4, 2, 1, 5, 4, 1, and check if it's only decreasing. Three, 4, Oh, so maybe we're supposed to ignore the index itself. It looks like we're supposed to ignore the index itself. So we're not increasing one. We stop at inner is less than I. It looks like we want to stop before that. So I minus 1. And maybe we want to ignore the same for maybe we want to do the same for non-increasing. I'll try the test cases again. Something about this one seems off. Something about this seems off. And my runtime was 8 my runtime was 8 seconds. Like, that's pretty crazy. That's pretty rough. $8,000. I'm actually top the leaderboard here for runtime and memory. I'm not even shown because I'm so out. Actually, accepted memory solutions was 6. It's not actually showing me where I am. So maybe there is a faster way to. I'm sure if I took out the console.log, it would be much better. Not by much, it seems. Why is it slow? They would like them in sorted order. Well, I think we can actually prevent the sort. I think we could remove the sort. I think it's because the time complexity of this is all over the place. We're doing a linear time operation, and then we're doing k operations, which at worst case, k could be n minus. K could be. I think it said it could be n over 2. Could at max be n over 2. So we're doing, which is still n, worst case. And we're doing this twice. Basically, this whole for loop in here is like n squared, and then we have indices sort, which is n log n. So it's like n squared n log n. You could remove the sort. I think you could remove the sort just by keeping track of all the good indices, and then you could just iterate over them afterwards in linear time. So what if we remove the sort, and what we would just replace it with is space, so we could have a hash, or not even a hash, a set basically. We could have a set, and this set is just going to pretty much keep whether or not indice is good or not. We'll call it the good set, and it'll just be a new set where it works with, it's going to store a number is going to be like the key. And then if this operation here is positive, we'll just say good set dot set I. And the way we would remove the sort is we could just iterate over the range, let I equals k, right? And I is less than, or just over the key. Oh no, we don't want to go over the keys because we don't know the order the numbers are in. But we just want to go over that natural sequential order. So I would be less than nums.length minus k, because it's the only possible valid range of good indices. And then we'll do I plus plus. We'll say if good set dot has I indices dot push I. And this should give us them sorted as well. So it does not exist on type set number. Oh, it's not set. I think it's add. So we still get the same answer there. Maybe this is, they set access should be amortized constant time, but this is like barely even faster. Still like 7 seconds, which is crazy. I wonder why that is. So n log n to n maybe is a marginal improvement. Maybe optimization could be done. Or I wonder, since there's 2 loops, technically there's 2 for loops, so is it technically n cubed? Because at worst case, it could do n operations here, and we're going through n times. I think it's 2n squared. Because I think there needs to be some sort of nesting, and there's no nesting here. But 2n squared is still crazy. Can we... Oh my god, I think I figured it out. What if there was a way you could know if a range of numbers was non-increasing or non-decreasing without actually having to check the whole range? Maybe that could be the sum. For example, we have 2, 1 here, right? If we sum these numbers together, we get 3. Which means maybe we have to be increasing. But when we say we're non-decreasing, I mean we're non-decreasing. We're non-increasing here. So our sum has to stay this. We're non-increasing, which means we're not getting bigger. If we're not getting bigger, it means we're getting smaller. Wait, the phrases are so confusing. Is in non-increasing order. If you're not increasing, it means you're getting smaller. If we sum this up, if you're non-increasing, the sum is only positive, I think. Whereas when you're non-decreasing, oh no, the sum is also still. I think there's something there with the addition. What if on the left side we only add them? So we'd say 2, 1, right? We'd have 3. And if we're ever decreasing, well, they could just put 0.5, which would mean we'd just go up 0.5, 3.5. So that kind of breaks it, actually. So that wouldn't work. What if there was a way we could know if a range is non-increasing or non-decreasing without checking the entire range? What if we could batch the work instead? So what if instead of doing work for every single indice, what if we just ran non-increasing and non-decreasing? Never mind. That would still be the same time complexity. Non-increasing, non-decreasing. Non-increasing and non-decreasing. I don't understand. This is strange. I wish there was like a solution so we could see why that is the way it is. Why that would be the way that it is. How could you make this faster? The non-increasing and decreasing means we're doing n squared. Going through, for each indice, we check to the left and right of it and then call a function. Oh my God. I think I just figured it out. What if we pre-calculated the ranges? What if we pre-calculated the ranges where it's non-increasing and pre-calculated the ranges where it's non-decreasing? And then the good indices would just be where they're separated by 1. For example, I think we'd still have to keep what we did before and start at k equals 2. So we start at 1. Actually, no. Yeah, you could just start. Yeah, you could start in the beginning. Never mind. So this is non-increasing, right? Non-increasing, non-increasing, non-increasing. And then this is the only range that's non-increasing. The rest is not. The rest is non-decreasing. And then what we would do is iterate through the array again and then find the range that is actually non-decreasing. Non-decreasing, which means where it's going up, and that would be 1, 1. I think it'd be like this. And so we'd have this range. I guess we can copy it. We would have this as, what is going on? And then for the other range, we would have this. And then I think the good indices are all the indices that are within the range K and all of them that overlap between I equals K, overlapping between I equals K and I is greater than or equal to K and I is less than or equal to N minus K. Right, so I minus K would be 5. Index 5 would be up to here, but the overlap ends here. But it would be indices 2 and 3. Let's try it with that other example. This one here. Let's try it with this one. All the non-decreasing ones would be pretty much 2, 1, and 1. And then the non-increasing one would be 2, 1, 1. The non-decreasing one would be 1 and 2. And if we take our range from earlier, right, it's I is greater than or equal to K minus I is greater than or equal to K. So 0, 1, 2, right? And I is less than 4 minus 2, which is 2. So is there any number in this array or any index such that it is greater than 2 and less than 2? No. Or with this overlapping range. So we would say no. So I is greater than or equal to K. It's greater than 2 and less than or equal to 2. So we'd have the indices, and then from here, that last bit is what bothers me. We'd have 2 indices left, or 1 and 2. Is there an indices such that I is greater than or equal to K? 1 is definitely not that. So let's check 2. I is equal to 2 here. What about is I less than? Is I less than or equal to 2? I see. We could change our overlapping. N has at least K, at least after. If we change our overlap, if we change the way we pre-calculate the overlapping sections, the criteria for the overlapping would solve that strangeness we had before, where you need at least K elements, right? You need at least K elements for an index to be non-decreasing, or for a range to be non-decreasing. So as soon as we get 2 here, we'll say, okay, this index, right, 1 or 0, 1, 2, the second, this 2th index, right, would be the only thing, would be the only index that is non-decreasing. And then if we wanted to find, or non-increasing, then we wanted to find indexes that are non-decreasing. We need these 2 elements to do that. And I think what we end up with is no overlap. Maybe this one here, and this one here. So there's no overlap. So I think we could actually make this work. Now I just have to think through exactly how the overlapping would work. We want to start with the direction. We want to go in the direction or iterate from the direction that's most natural for the criteria. So non-increasing makes sense in the sense of going from left to right, because you need at least K elements first, and then afterwards you can just verify whether or not that's true. Non-decreasing makes sense from the other side because you need at least K elements. So right, this is not gonna, this wouldn't be 1. Pretty much want to make sure that they're getting smaller, but you need at least 2 elements. Need at least 2 elements which have already been smaller to say that this index is smaller. So in reality, 3 shouldn't even be included here. I think there's, yeah, we just want to know that we've been getting smaller. You need at least 2 elements first to say that this one is getting smaller. So our true range looks like this. Then it breaks at 3. And then our true range yeah, it looks like just the overlap should be the solution. And if we could do this, that would be linear time with linear space overlap. You could also visualize it as like a hole or like some kind of concave structure. And it looks like what we're trying to say is non-increasing means like we're always going down, even if we end up going straight for a little bit. We're always going down, so it's just like this, and the right side is like this. And they're asking for all the numbers that live in this centerpiece here, except there can be multiple troughs. Okay, so I think we could do that. So I think what we can take away all of this, and what if we just did? We had an array called non-inc. Is going to be an array of indices. It's going to have to be parallel to number. And we'll just have two of them, non-decreasing. Say for let I is equal to 0. I is less than nums dot length I plus, and then for each index, right, where we can determine that it has at least k indices before it that's non-increasing or non-decreasing, we'll add a 1. But to start, it's kind of like a boolean flag array or a boolean array. We'll just say non-inc dot push 0, so we'll just set them all to be 0. There's no overlap to begin with. Then we'd have indices at the end, which would be a function of the overlapping, and then needn't calc non-increasing, that would start at I, and it would go until nums.length minus k. We'd have a value maybe called decreasing. Let me see which one's first. It is non-increasing. So say non-inc nums would be set to 0. And say if non-inc nums is greater than or equal to, no, if non-inc nums is greater than k, then we would say non-inc sub I would be equal to 1. Then we have another if statement. We'll say if num sub I is greater than or equal to num sub I plus 1, I'm going to say non-inc nums plus equal 1. Otherwise, if that's not the case, then it must be decreasing. Or it must be increasing. And we're going to set non-inc nums equal to 0. And then we're going to console.log non-inc. And so we should just get Maybe we do want to keep that equal to. So we get this overlapping range, which is indexes 2 and 3, which makes sense. So what if we duplicate this, and we'll just change this to non-deq nums. And we're actually going to start in reverse this time. Length minus 1, and we'll say, well, I is greater than or equal to k, where we want to stop. And then we'll do I minus minus, and then we'll say non-deq nums is greater than or equal to k. The non-deq of I is equal to 1. Okay, apparently we have no non-decreasing numbers. So you start at 1, check if, oh no, we should be checking if num sub I is greater than the next number. We'll include that last index. And then we should just be able to do for let I equals 0, I is less than nums.length I plus plus. And it should be sorted too, and we'll just say if non-deq sub I and non-inc sub I indices dot push I. Let's try it with the non-overlapping one. Oh my god, I think this is it. Oh man, this is that one from earlier. How did we fix this? We were including the last number. This would be a simple fix. I don't remember what we did. The issue is that we're including or including k itself somehow. So we do not increasing numbers. Oh no, wait, I think I just did the opposite. Zero, 1, 2, 3, 4, and 5. We ran out of time, but I think we can fix this one tomorrow. But I would say that is a wrap for today.